Okay, for today's sub classwork, I'm going to have you watch and finish yesterday's packet. I have extras if you need one. I'm going to collect this at the end of the period, have you turn this into the substitute, finished or not. I'm also going to collect last night's homework if you finished it, and any other makeup work, turn that into. So I'm going to collect all of that, or have you turn all of that into the substitute. Alright, so hopefully you have yesterday's packet or you've grabbed a new one. Okay, for this first problem, I'm going to explain, and then the other 4 or 5, I'll let the ghostwriter just do them for you. So this first one here, again, I'm having you dilate through the origin along these rays that follow the slope through the origin through these points. So from the origin to point A, I'm going over 4, up 4, over 4, up 4, over 4, up 4. I'm going to draw a straight line through those as best I can, knowing that each point along that line will be the new spot for this part of the triangle as it grows bigger. B, I'm going over 4, up 1, 2, 3, 4, 5, 6, 7. So over 4, up 7. I think that's 7. 1, 2, 3, 4, 5, 6, 7, 8. So that's right 4, up 8. Right 4, up 8. 1, 2, 3, 4, 5, 6, 7, 8. The more you can say it, the better. Right 4, up 8. Sorry, this one went off the chart a little bit. And then the last one here, through point C, 1, 2, 3, 4, 5, 6, 7, up 4. 1, 2, 3, 4, 5, 6, 7, up 4. Right 7, up 4. Right 7, up 4. Right 7, up 4. Keep saying it, and you'll have less a chance of messing up. Draw your line through it. And then again, each of these marks as you go up the line will show you the new vertices of these triangles as it grows bigger. So the first one is given to you right here. If I double this length along this line, it gives me the triangle doubled. So that's the triangle originally here, doubled up to here, scale factor of 2. And then I'm going to go up the next dot up here a little bit off your grid, sorry about that. So up to here, down and across. That's the triangle from its original position down here, tripled 3 times the distance. 3 of these original distances tripled, scale factor of 3. I need you to be able to prove any 2 triangles are similar by putting the lengths of the triangle in the right spots to make them correspond and give you 2 equal fractions. Prove to me they're similar. So I'm going to have you choose for this problem. I'm going to do 1 and 2. And again, it's all about the lengths. Count the number of boxes. Those are your lengths. Count them. This one is 6. Going up, this one is, I believe, 8. Count the other ones. This one at the bottom is 3, and going up 4 boxes high. And then the big one, count them, count those boxes. So again, if I'm comparing 1 and 2, looks like I'm starting with the height over the length, so 4 over 3. As long as I use the other numbers in that triangle in the lengths and do it in that order, I'm proving it similar. So 4 over 3, as long as I do that same order, 8 over 6. And again, those 2 are equivalent. If I take 8 over 6 and reduce it down by a 2, divide it by 2, or reduce it, it reduces it down to 4/3. So it shows those are equal. Those are equivalent. Shows me those triangles are similar. I could have done any pattern. Remember, different patterns will also give you equivalent fractions proving similar triangles. Alright, scale factor getting bigger. I'm going to go from triangles, looks like, what am I doing here? From triangles 1 to 2. doubling. To get that scale factor of 2 doubling, again, you're using the lengths. You're putting the new length on top divided by the old length. Or you're putting the length of the triangle after it got enlarged. That's the new length from this original to this new one right here from 1 to 2. This is the new expanded length that goes on top. The length that it started from, that 3, that goes on the bottom. So to get that scale factor of 2, using those lengths, the new length as it gets bigger is 6. And the original length where it started from was 3. So if I divide 6 by 3, that gives me the scale factor, which is 2. 3 divides into 6 2 times. That's a whole number. Bigger number on top, smaller, that's a whole number fraction, whole number. If I'm going down from maybe 2 down to 1, again, where it starts big and shrinks down, the triangle number 1 shrinking down. Going down. So again, the formula is always the new length over the old. So if it's starting here and you're shrinking it down to this shrinked length, the smaller length, is the new length after it got shrunken down. So that goes on top. That 3 goes on top. The 6 is where it originally was. So you put that on the bottom. And if you divide those out, that gives you 1/2, the scale factor. And again, you could use other numbers. If I did 4 over 8, I would have got 1/2. Again, the new length over the old. And again, those scale factors make sense. This triangle cut in half gives you 4 and 3. Or these numbers times by 1/2, which is the same as dividing by 2, cut it down to 3 and 4. 8 times 1/2 is 8 divided by 2, 4. 6 times 1/2 is 6 divided by 2 is 3. Going the other way, from 1 to 2, doubling it, 3 to 6. 3 times 2 is 6. 4 times 2 is 8. Going from 3 all the way up here to this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. From 3 to 9, tripling it. And I get that again by dividing the new length. 9 by 3. 9 divided by 3. 3. Scale factor of 3. Alright, the other ones I'm going to have the ghostwriter do for you. Good luck. So as this last problem's finishing up, make sure you turn in everything today. You're going to turn in this packet, finished or not. You're going to turn in last night's homework if you did it, and any makeup work if you have. Again, know how to find similar triangles, how to put the numbers in the right place to get equal fractions, and I'll go back to that. I'm sorry. And know how to use scale factors and realize what's going on with scale factors. Scale factors going up, timesing by a whole number, going down, timesing by a fraction. Good luck.